Hi, welcome to another video tutorial. In this video tutorial I'm going to be going through the 4-layer TCP IP model. And let's deal with what TCP IP stands for first of all. So this is an acronym for Transmission Control Protocol / Internet Protocol. And this is a set of protocols that work as 4 connected layers, and they pass incoming and outgoing packets up and down the layers during network communication across the internet. And you only have to know about the 4-layer model for GCSE and A-level. If you're going on to do computer science at university, there is a more advanced version of the TCP IP model that you'll learn. But what are these 4 layers? So the 4 layers are the application layer, the transport layer, the network layer, and the link layer. Okay, so what I've done here is drawn a little diagram, and what we're going to consider is a computer 1 here, so PC 1, sending a string of text to PC 2 over the internet. And before we go into what each of these layers of the TCP/IP model means and what's happening at each layer, what's important to understand is that at each layer, the data that is being sent is wrapped in an envelope containing new data, so new what you might call metadata, and as it descends the layers, so going down from the application layer at PC1 down to the link layer at PC1, where we've got our initial data here being looked at the application layer, and then we're wrapping more and more metadata around that initial data in the packet that we're sending as we descend the layers. And then when we get to the routers along the way, and when we get to PC2, we're unwrapping it so that we can look at some or all of the data. Okay, so let's first look at the application layer. So you need to be aware of the protocols that operate at each layer of the TCP IP model and the overall role of each layer. So the role of the application layer is to select an appropriate higher level protocol such as HTTP or FTP or a protocol like that for communication. And as you can see here, the application layer is on the top of our stack here, and it uses protocols which sort of relate to the application that you're using. So a browser might use HTTP. And as we go through explaining these layers of the TCP/IP model, I'm going to give you an example of the actual data that we're sending at each layer, so suppose we're sending the text, this text over HTTP. So we're going to send this quote from Alan Turing over HTTP, and so the application layer selects an appropriate high-level protocol to do this. So our application layer in this example is going to select HTTP, so Hypertext Transfer Protocol, and that's what we're going to use to send our Alan Turing quote. So that's the application layer. The application layer takes the data that we're looking to send and decides on a protocol such as HTTP to send it over the internet. Now we're going to look at the transport layer. Okay, so we're looking at the transport layer now. We've done the application layer, we've selected our protocol that we're going to use. We're going to use HTTP as our higher level protocol, and the transport layer now we've come down to it, does a number of really important things. The first thing it does is that it splits the data into packets, which are manageable to send over the internet. So I'm now going to split our Alan Turing quote into packets. Okay, so I've split the text in our Alan Turing quote into packets. And the second thing that the application layer does is that it decides on a port through which each packet should be sent. and this port number is included in the packets. And because we're sending our data over HTTP, the port I'm going to pick is port 80. Okay, so I've included that information in the packets. And the third and final thing that the transport layer does, which is also really important, is that if some of the packets get lost during transmission, the transport layer will request a retransmission, and it also acknowledges successful transmissions, and that will happen at the transport layer PC2 here. Okay, so just to recap then, the transport layer splits the data into packets, decides on a port, so we chose port 80 for HTTP, and handles packet loss by requesting the data again. Now we're going to move on to look at the network layer. So what's really key about the network layer is that the network layer adds source and destination IP addresses. So it's important to remember then at the network layer that these sender and destination IP addresses do not change through the course of multiple hops between routers. And that's because these sender and destination IP addresses are used to make long-term and long-distance routing decisions across the internet. So if, for example, there was a network like this, where all these black dots are routers, and this is my sending computer here, and this black dot here is my receiving computer, and the packet has started to move down this route here, but now it finds ahead that this route here is blocked. So it will then use the sender and destination IPs to decide to move across this route to successfully transmit the packet. Okay, so I've added some sender and destination IP addresses, and let's just run through what the network layer is for once again. So the network layer adds the source and destination IP address to the packet, to each packet that's being sent. What it then does, it also has one more job. It then uses an IP address and a port number to form a socket. And an example of a socket in this example could be 43.65.120.12:80, because we're using port 80, so that's a socket. If you want to know more about sockets, you can look at my specific networking videos on that, on sockets and ports and things like that. Moving on then, I'm going to take a look at the link layer. So the link layer then is the physical connection between network devices, and it adds the MAC address of the destination and sender network interface cards. So the link layer adds the MAC addresses of destination and sender network interface cards. The MAC addresses that are added at the link layer are changed at every hop. So you can imagine this router here, to send a request from one PC to a server somewhere on the internet is going to take several hops through several routers, and the MAC addresses are changed at each hop to reflect the new sender and destination MAC address. So this is an example then here of what the sender MAC address and the destination MAC address for each of these three packets might be on this hop from PC1 to this router here. So let's now take a look at what happens when the packets get to the destination. So we've got the link layer here, and the MAC addresses are stripped off each of the packets at the link layer, and then the packets are passed up to the network layer. So we can remove the packets' MAC addresses. And then when the packets are passed up to the network layer strips off the IP addresses and passes the packets up to the transport layer. So we can remove the IP addresses from here, and then the packets are passed up to the transport layer. What the transport layer does is it uses the port to determine what application the packet should be passed to in the application layer. Then it strips off the ports, puts the packets in the right order, and sends them up to the application layer. So our packets are already in the right order as we've written them down. And then when the data is passed up to the application layer, the application, for example, Google Chrome, if I'm sending data over HTTP, displays the data to the user, in this case our quote. So we can just simply remove all of this, because they're not in packets anymore. The data is being displayed to the user by the application. Okay, so that is what happens at the receiving end. Now, you might want to know why we've got the link and the network layer in our diagram for the TCP IP model for each router, for each hop. And that's because when a router receives a packet, what it will do is it will go up to the link layer, strip off those MAC addresses, then the link layer will pass it up to the network layer. Then what the network layer does, it doesn't change the IP addresses, the sender and destination IP addresses that we had earlier, but it looks at them and uses them to decide long term which set of routers the packet is going to be passed through. Then what happens is that it passes the packets back down to the network, to the link layer. The link layer puts on the sender IP, the sender MAC address, which is the router's MAC address, and a destination MAC address, which could be another router or it could be the final destination MAC address, so the MAC address of PC2. So that's why we've got the network and the link layer for each of these routers there. That's what happens at the network and the link layer there. So I hope that's all made sense, and it's quite a difficult concept to get your head around for the first time, but once you do, it all makes sense quite nicely. But if you have any questions, do let me know in the comments of this video, and I'll try and answer them as best I can. Okay, so I hope you found that video useful, and thanks for watching.